Welcome, everybody. Really appreciate you joining us tonight. This is Ted Gauthier in Pontiac, Michigan. We're starting our first CNC Fourth Axis Rotary webinar. Our host from now on will be Talley Boatwright. Talley is the main administrator for a Facebook group called Fourth Axis Rotary Setup and Projects on CNC. So if you're not a member of that Facebook group, feel free to jump on over there sometime, and it's a private group. Get invited to participate. We'd love to have you. But in the meantime, what we're going to try to do is have a Fourth Axis Rotary webinar every once in a while. We don't know if we're going to have it twice a month, once a month. It depends on how much interest that we have. But we'll try to have these often, and we'll see if we can jump around and get different topics of people's interest. So with that said, what I'm going to do is we're going to give this to Talley Boatwright, and we're going to let him run with it, and he's going to be our main host for all of these webinars, and we'll see what happens along the way. So Talley, this should be yours.
Good evening. Welcome to the Fourth Axis webinar, the first one that we're going to demonstrate. In this particular webinar, we're going to go over setting up stock designs from a stock square piece that normally most softwares recognize as a turning piece. Normally, the software that we use usually show a round stock, and it assumes that every piece of stock that we use for turning is round. In this webinar, I'm going to show you how to skip that and actually trick the software into thinking that your piece is already round and getting the maximum size project out of a square stock. Okay, so let us open up Aspire. In this demonstration, let's start off with a new design. So we're going to create a new file, and in this file we're going to assume that normally I've turned out of a 5x5 stock, which is really normally like a 4x4 or a 5x5 or anything like that, just a regular construction stock that I use. In this case, the main point is you want to measure the diameter from corner to corner of the piece that you're using instead of actually the square side. So I know that a 5x5 is actually 7.5 from the corner to the corner. So I will put that in my dimension as far as the diameter. And then on the length, what I would do, I would just measure out how much I want to work with. So my image will actually go into those dimensions. We're going to zero our Z in the center axis of the cylinder. The offset, that is a matter of choice. Most of the time, it will be 0, 0. On some machines, you can do your offset where it doesn't start maybe between 2 to 3 inches back away from the stock of material. In this case here is -1, so it's going in 1 inch into the stock. When I set up on my stock, I do 4 inches back. So my work origin is here, and then it moves forward towards the stock. In this example, we're just going to say 0, just to keep it simple. Depending on the orientation of your machine, if you're running along the x-axis, then it would be here, which would be your a-axis. If you're running parallel with your y-axis, then it would be the b-axis, which will be parallel to the y. In this example, we'll say that x-axis, and then we would just click OK. Now, once we do this, what we have done, we're actually skipping the gadget rounding tool paths. We're just skipping that one. And we're going to import a file, excuse me. So I just previously chose a file that we would actually set up the turn. And this is the file. We will change the model diameter. We're going to make the model diameter at 4 9/16. This way, you will have just enough material left for clearance, and you won't have any flat spots for the carving. This will allow you to use the maximum size of your material that you have without wasting. As the material carved in the roughing, it will take in consideration those highest points, and it will automatically cut off all that and go down into the rough area of the stock to start carving the model. You should not have any air cuts. But we'll, from there, we would say, okay. And here we have the design. To bring up dual pages, I hit page up. So now that'll bring me into the 2D view and a 3D view, so you can see. I will not go into the editing functions for this seminar. What we want to do, I just want to create some tool paths to show you what it would look like. So we'll create a roughing. I would do it as with a 3/8 bit, just for reference. I run my machine pretty hard, so I would say realistically a feed rate of 150 and a plunge rate of 120 is sufficient for this application. It's a small piece, and we'll select OK. And then the Z-level roughing, that means it will rough in the Z by levels, which Ted pointed out in the new version of 10 that I've noticed that it actually added order, which level by level, and you have depth first. The level by level, it will continue to rough until it reaches the past depth that is set by the bit. So for every level, that past depth will be taken off a 1/4 inch. You can run a little bit more aggressive when doing that, but I suggest if you're running this, if you're going to run this a little more aggressive on the past depth, your step over needs to be smaller. That way you're not engaging too much of the side of the bit into the material. So you have a little less friction. So you can run a little bit more aggressive with that. And then your depth first meaning that it will engage and rough down until it reach the rough and suggested area before it either rotate or engage into another piece of the stock that has not been cut. I also suggest using a ramp plunge. This also takes stress off the bit. Normally, I would run maybe like a 3/8, or you can run higher. It would do a zigzag as it engage in before it start initializing the actual cut. And then we would save this as just a regular rough. You can actually select control and calculate, and you will automatically get the tooth path. Whereas if you put calculate, it will show as the 3D image. You won't see this happen right now. So let's look at this view. So as I turn the model, you will see that it has cut everything around as it engages into the levels until it start roughing the actual design. So you shouldn't never clip the corner of your stock. It will treat it as if that stock is round, which will start cutting the highest point first and working its way down into the low spot. It actually saves a little time, so you do not have to try to set up a rounding stock and setting up different tools. You're just using your regular roughing tool, and you can start carving the model right out. And like I said, you can get the maximum amount of size model out of that piece of stock. So if let me show you in the setup, if you didn't do it this way and you just set up the stock as a 5x5 or 5 inches, your clearance would have to be the radius of your diameter. Now, I'm not sure if Aspire 10 compensate for that in the new software, but I know from 9.5 and back, the earlier versions, if you did not put the clearance path, the clearance Z, half of the diameter of your stock, it will collide because you won't have that clearance. What it would do, it will clip those corners, and either you'll break a bit or you will stall your machine. Doing it this way is the shortcut. If you put the diameter size in there from corner to corner, from each corner, then these values here will compensate to here, so that means you still will have your clearance. So that's something to keep in mind. And then we're going to do a finishing path.
Question.
Yes.
If you look at the neck of your model as compared to the widest portion of the model, what is the difference between those areas? What I'm leading up to is, what is the length of your carving bit? And do you have a cutting side all the way up the cutting surface? It looks like it might be 1.5 inches or 2 inches. And a lot of those bits are only 2.5 inches long, and it leads to a fair amount of stick out,
Right.
which alters your feed and speed, etc. So I'm puzzled by your setup of the tool that you are using from the point of view of how long it is, the cutting surface, and the amount of stick out of the bit.
Okay. My roughing, what I use, I use a 1/2 inch compression bit, which is a Yonako, and that bit has actually about a 2-inch cutting length. So the overall bit is maybe about 3 inches. If you cut in the levels, you would never stress that bit out as long as you cut in those levels. If you do a full depth engage, that's when you come into a problem of stressing that bit out, because when that rotary is turning, you have the bit cutting, and that the rotary is actually turning into that bit. Either it's going to turn into it or it's going to turn into the backside of that bit, and that's going to automatically put that load on that bit regardless. But by cutting in the levels, you are allowing the machine to cut at a normal rate, which maybe even if you took off 3/8 at a time, it would still allow you to cut a little faster than trying to plunge at a deeper depth. So it's a safe way to do it, because if you normally try to run into the thickness of that material, you would definitely break a bit. I have never roughed with the rotary with a 1/4 inch bit. I've always done using either a 3/8 bit or a 1/2 inch bit. I feel like that's safe to me. I mean, I would do some more testings and see if it's possible for me to run with a 1/4 inch bit and see what's a safe speed to run. But I just have never felt comfortable with doing it, because your initial roughing is a very aggressive cut.
Okay, I understand. Thank you.
You're welcome. Let's add a finishing toolpath to it. So I'm going to add a 16th inch tapered ball nose. I run a little high, so normally I run my spindle speed at 15,000 RPMs, regardless. My spindle tops out at 18,000. I run most of my carvings at 15,000. I have ran as low as 12,000 RPMs, and I usually control my cuts with my feed rate. So I can run as high as 400 inches per minute. Usually that's what I run on most of all my carvings. And with this size bit, this 16 inch, I can do a 15% step over, which is pretty decent, and give me actual good results, and it takes off time on the machine. So we're going to go with that. So pretty much keep in mind that you need to check the specs for your machine as what it's capable of doing it. I know Dr. Batts, you running a Legacy, your machine is capable of doing 600 inches per minute easily. So that won't be any strain on your machine. So we do that, and we'll finish a 2-path and check the results. I also want to mention, in Aspire, I found that roster is a better two-path strategy than doing an offset. What I have noticed when you do an offset in Aspire, what happens, the Z has the tendency of raising every 180 degrees. So when the rotary turns 180, the Z raises and then it comes back down. I haven't seen anything where they have corrected that. So I don't use the offset on in Aspire because of that. I always use a roster, and in most cases, I would either run it at 90 degrees, where it's constantly running parallel to your stock piece. By doing that, you can also gain a little bit more speed with that axis. You can move faster. If you do it at 0, then what it would do, it would just actually try to just turn and move the steps over, which would take a longer time to carve. Then that means you have to actually speed up the rotating axis to compensate for less time. So if you can, run parallel with the design, and you can actually speed up the machine, and it won't put any more stress on the bit load at all. Okay, so now we have the finishing, and we're gonna look at the finishing, and there we have the design with the finishing two path, and let's see how it look with all the two paths. Okay, so that looks pretty good. Let's get an estimated time and see. So it says 5 hours in this. Realistically, it will probably take a little less time, considering the machine. But I want to also show, we're going to go back in here. I'm going to show you how to change this design up to force the machine to carve in a designated spot. In other software such as RhinoCam, Fusion 360, DestProto, Mastercam, those programs have what they call region containments or segment machining. Aspire does not offer that feature. So in this case, we would cheat. And it's the same method that you can use for rest machining. So in this case, what I do, I just take the draw rectangle tool and I draw me a rectangle around the area. And normally what I do is I would do the math and I split up that rotation. And what you have done, you have changed the tool strategy from just normal carving on a rotary to an indexing, because now what you're doing, you're going to force the tool strategy to stay in this area by selecting that. So I copy and I paste and I bring that down. And if you notice, I would do just the overlap. Then I'll do it again. Paste. And I'll bring that down. Just enough overlap. And do the same thing. And once you start doing this, I mean, you can actually have a little fun. Like it's no particular order that you have to pick these in to make it machine. It's all according to, if you want to sit down, you want to watch your machine, just do some crazy stuff. It's just fun to watch. So we'll bring this up. And I'll show you exactly what I mean by this. Okay. So what we'll do, we're going to go back in here. And then we're going to say, select vectors. And from here, we'll select this one. And we can select this one. And then we'll select the actual image. And then I'll show you. You'll see exactly what it does. We're going to reset. And then we're just going to say, select the tool path. So that's actually how you force the machine, force the software to stay in one area to carve. You're not wasting movement. We'll go back in and let's say, we'll go back in and we'll edit that. And then we can go edit that. And the same thing applies to rest machining. If you're doing rest machining, I do the exact same thing. And we'll say, oh, I'm sorry. If you did that, I'm sorry. If you did that, you would actually, hold on. You will actually set it as another tool path. You'll go back in and set it as another tool path. Okay. So now you have that, and then you would do that. And you would actually, you can do the same thing with the finishing. So it would, the machine would actually stay in that area until it finished. It will not move. It would just stay right into that area until it finished that area, and then it will turn to the next area. And that's how in Aspire you can actually make it do index and machining. Any questions on that one?
So if we run that in the finishing, can we see how much time that we would save?
Yes. So let's do, okay, I will, I'm going to do the same thing in the finishing also. Let me see. Yeah. Okay, and then we're going to run a second pass. So a total, let's see if that's right. So a total time of 1.5 hours, almost 2 hours. But that's really according to your machine. If we look at it, it should take, the rotation should be less as far as the machine keep turning. Let's see. Wait a minute. So according to the way it's processed, it should turn from 0 to 90 to 180, 270, and then come back to 0. Instead of going back and forth along the axis and gradually turning. So let's see. So that's 1 hour. That's 49 minutes. That's 1 hour. And that's an hour and 16 minutes. But it can be sped up. That's another way to contain your carving also. Instead of doing the entire carving, you can contain the tool paths into one segment where to just stay in that area. So that's just an option, and I use that method in this software and in other software, which the other softwares have. They have a better feature. You don't have to do it manually. It actually has the feature for that to be done. Any questions on the containment? Yes.
You could use that in case you're up on a deadline, you got to leave the shop, so you could carve just part of it and then stop the machine.
Correct.
How do you do alternate ways? If you had a 33-hour carving, you're going to use the whole 5 foot of a legacy and it's 11 inches in diameter. Do you just put in fake tool changes every couple of hours to give yourself a break? How do you stop without losing your position in a manner other than what you just showed us?
Okay. I'm familiar with Legacy and using Mark III also. I have a different controller now. I have the rich audio controller, so it's a little simpler for me to do it on my controller. With Mark III, Mark III will allow you to save your work offset, and saving that work offset is going to save your actual work coordinates that you record. With that, you can do one or two things. Once you save that, you can stop your machine, and it will ask you, do you want to save that work offset? You can say yes. Once you say yes, it automatically record that. Whatever offset you was probably on, more like G54. I think it's its default. But you can choose to save it as 54, 55, 56, or whatever, etc. And it will save that. When you fire up your machine, when you come back, you fire up your machine and you home it, you could tell it to go back to that G54 and load that program. Well, let's see, because I'm trying to think if I can't remember. Does it remember the line code? In Mark III, I write down the Mark code, whatever line code it is, as a safety precaution. I write down the line code. Okay. And usually I will go back 30 lines. I will go back 30 lines before I stop. That way it'll go back over the carving just a little bit, so you won't have any tool lapse. But if you tell it to go to the G54, it should start right back where it stopped. Another thing I have done also, when I first started learning Mark III, I would just pause my machine. I would just pause. If you could just pause your machine and turn the spindle off, and it should not lose position. And I came back out there the next day, and I just turned my spindle back on, and I just hit run, and it'll start back. If you're running a rich audio controller, we have what they call breakpoints. When we stop the machine, it asks, do you want to save that breakpoint? And it's the same way as Mark III. The breakpoint is our work offset, but they're not recorded as G54, G55, G56. They just say work offset, even though it is G55, G56, or whatever, but we only have 9 offsets. And you record that, and that's it. You just say yes, and it automatically brings up the name of that file. You turn the machine off. The next day you come back out there. You home the machine. The axis is going to turn back to 0. And when you home the machine, and on the rich audio controller, if you press OK, the screen will come up and it'll say, do you want to go back to your work origin? You press OK, it goes back to that work origin. You press run, and no, I'm sorry. You go to the break point and look for that file, and you start it, run, and it will start back again. And it would do that on a power failure. If I can actually do a carving and just slam the stop button right in the middle of the carving, and it's going to remember where it was. When I turn it back on, it'll go to home, it'll come back, it'll do the same thing, and it'll start right back to the position.
Thank you.
You're welcome. Any more questions? Okay. Let's see. The next thing that I would like to go over. Can we switch screens, Ted? Let's switch screens. Thank you. In this demonstration, I'm going to show you a software that this software has been around for a while. It's getting a lot of reviews now. I personally like working out of it because it's simplistic. Once you get the hang of it, it's very simplistic. But it's DestProto. And the reason why I say I like to work out of DestProto, because DestProto allow you to bring in files and just set them up and just run. It has more advanced features than Aspire, whereas it doesn't cost as much as you would try if you would have bought software like Mastercam, RhinoCam, and etc. So with this, I'll show you some of the tool features and how easy it is to set up a file for a rotary axis. And this actually has what you call inverse machining, where it actually takes the G code, and instead of using it as I can't think of the name of it, but it actually used the G code where it does a constant turning. So your machine is turning much faster. So I will start with this, and I'm going to actually bring in the same file so you can see the tweaks that I would do to it when I run out of this program. So in this case, I have two setups for this. I have my table set up and I have my rotary set up. Now, the reason for that, because that way, since my rotary is set up on the B axis, it has to actually convert it, the orientation of it. So we're going to do a rotary machining, and we're going to hit next. And this is the wizard. So the wizard allows you to just bring in files, set them up real quick, add toolpaths, send them the G code, and you're ready to go. So in this case, we're going to bring in the same file. And I import that. And then we put in the dimension. In our case, we're going to say the same thing. 4 and 9/16. And then we need to rotate that so we can get a center axis. And then we're going to keep the center geometry a round rotation axis. We hit apply. And then we hit next. And then from here, this is where we change that stock piece, the Z. We're going to change that to 7.5. Whatever length your stock going to be, It doesn't matter as long as it'll fit in that area. And then we're going to do, you can add supports. Supports are custom if you would like. And I'll show you what that does. That allows you to make these larger. In such case, I do, because I do not want my bit carving and actually to the depth of the stock and running up in the back of it. So I do that. We'll change these to cylinder and keep these about the same. That should give enough. That should be all right. Oh, wait a minute. What's going on here? These numbers have to be the same to make it round. If they're not, you see, you get more of like a oval effect, like that. And then we'll change the front. We can do the same. We may not can get that one because of that tip. So that would be fine if we do it like that. The workpiece origin, the center, and the depth, suggested depth, will be half of the diameter of the, well, it'd be the radius of your total stock. And then we hit OK. And then you select your tool. In this case here, we can get away with a 1/2 inch. The distance between the tool path is the step over in DestProto. It's the same as in Aspire. It's a little different because it's the diameter divided by 3, 5, or 9. In the manual, it explains how it works, but I found that by working out of it, normally a 5 for your roughing will work, and for finishing, a 9 is pretty sufficient with your smaller bits. The feed rate, it is inches or millimeters. However, they did not update the for it to be imperial readout, but even if you put in 400 or whatever, it still reads it because the software is set up for imperial. In this case here, I run mine at a top speed because on my controller, I've disabled the feed rate readout. That way I can control my feed rate actually on the fly. And again, I only run my spindle at 15,000 RPM. In the strategies, you have a bunch of strategies that you can actually use: parallel, crosswise, block, offset, waterline. We use parallel. Waterline, let me explain what waterline is. Waterline is when you have a file that off the shoulder of that file, of like right here, it drops 90 degrees. In software like Aspire, it does not recognize that. The only way to get away from that is you have to put a draft on that image, so you have a nice little slope. In this software and waterline, you can actually do a containment, like I showed in Aspire, drawing a box around it. And what it allowed it to do, it will allow that tool to drop right there and just cut all the way around on that area and you will not have no chatter around there. That's what the water line does. And you set that up as a separate tool path. So once we do that, we're going to calculate the machining for that. Okay. So this is what this look like. And let me go back. Let me go back right here. Where you say layers and thin. This is the same as far as what the layers you want to leave left, the skin for your operation. But right here, this allows you to use the length of the cutter that is programmed in the software. When you do that, the software will calculate what they call a dynamic feed rate. What it does, even though you're using the full length of the cutter, the software will calculate the chip load of that cutter. If you can see those zigzag lines right there, it uses that to control the stress on the Z to make those cuts. You can actually choose your pass depth. The custom is actually your pass depth right here. So you can change that. If you use this and I calculate, you'll see this change. You see the difference? So instead of now, it made all those layers. Now what it controlled the ramping, and it took it down to like 3 or 4 layers instead of like 6 or 7 layers, which added time. So that time now dropped significantly. So we'll go to next, and then from here we'll just choose. I just choose a small radius tool right here. And we're going to bring this down. 17 is a little bit much. We'll do like 9. And then I bring that up. I'll say 15,000, which is 600 inches per minute. And then we'll do 15,000. We'll keep that. And because once I do this and show you, I go into it and I'll make some tweaks. I'll show you some other little stuff. Ted, are we fine on our time?
Yeah, I think if we wrapped it up the next 5 to 10 minutes, we would have one.
Okay, excellent. Any questions about this process?
I think it's very interesting to see the difference between the two types of software and how they attack the same model.
All right.
This generates G code that you can feed right into Mach 3?
Yes, it does.
Do you use Mach 3, or with your controller, have you switched to a different G code reader?
I can actually use. I have to try it. I can use the Mach 3 extension because Mach 3 use text, tap, NC. What else it use? So my controller read the same thing, but I haven't tried a Mach 3 post on it. I use .mmg, tap, NC, and ISO. It can read plot also, .plt. I would try maybe sometime tomorrow. What I do, I just do a random file and see if I can actually run a Mark III post, and then I'll let you know. But yes, this software here handles mostly any controller. If not, it can be tweaked, because I tweaked my controller for the rich audio. I tweaked the post for the rich audio. Okay, so in this one, do it an hour and 20 minutes on this. And then you click here, and we'll just say, and it writes the code. So we'll just say pineapple.
Was that an hour and 20 minutes for the whole?
Yes.
And in Aspire, it was almost 5 hours.
Right.
What a difference.
Right. And remember, I told you, this one here has the inverse time feed rate that it automatically does, and I'll show you in the code once it does it. And let's see, we'll say we finished. Finish that, and then we'll just go right in the code, and there you have it. And it's right here. You have G94, and you have G93.
Okay, so you have some guys, I think, in the room that probably aren't familiar with what the difference is between intermittent and inverse time rotations per degree. So with the difference between G93 and G94, you might want to quickly explain that.
Okay. So most in Aspire, Aspire does not have G93, which is inverse time machining. So what it does, when it calculates a rotary turn, it does it in degrees, if I'm not mistaken. It does it in degrees. And when it does that, by doing it that way, it's not as the fastest method. So don't take this into it's being like, because I'm still new at it. So I mean, when I describe it, the research that I have on it, I know that it's not the fastest method of carving. And Ted showed me what was the software, Ted, that you showed me that does the conversion?
It's called Rapid Rotary.
Rapid Rotary, yes.
It's made by Sean Gano with Gano Technologies. If they want to search it up on the internet.
Correct. So when you convert from the degrees into inverse time machine, what it does is it converts those degree rotational axes into a higher feed rate, which you will see right here. So now it's more like turning the axis is much more as RPMs instead of in degrees. So you're just converting it to rotational speed now, which if you look at some of I would say some of legacy videos, because I've spent a lot of time studying like legacy videos, you will see that the speed that they actually turning in some of their videos, but it is solely done by the software. You can add that code in there in your G code. If you know where to put it, you can add it in there. And normally it goes right after the G0 and after your first movement. Then you could say G93, and then as you go down, let me go down here to the bottom. Then you convert it back to the G94 and run it. And I have done that as well, and it works. Any questions on that? Okay. So, Ted, did you want to cover anything else in this segment?
No, I think wrap it up here. We'll close it on out, and we'll let people know what we are doing here. And what I'd like to do now is just thank Talley for offering to do these webinars and help us learn. I just want to make the point here that it may have gotten a little bit advanced for a lot of us. There's many people that are just new to Rotary, and that's what we want to encourage. We want to encourage people that have thought about getting into Rotary and have not made the step yet. So we would like to do everything from beginning towards advanced, and we would like to make this a networking type of place where we get other people that know different aspects of Rotary, and we can all help each other. So when we have questions, we're just getting into it, and we say, hey, how do we even just take a piece of square stock and put it in our Rotary and set it up? We'll have people here that can answer these questions. And my goal is to make a little library so that when someone has a question down the road, we're not reinventing the same wheel again, that we'll have videos up on YouTube and we can say, hey, we talked about that. We got an hour video that we recorded and we put it up on YouTube for you. So this is the very first one. We have some learning curves hurdles to get over, but I think everybody bared with us. And I just like to thank everyone. We are not scheduling these on a daily basis, but if you want to be, if you're watching this on video, just send a email to me at ted@flyballoons.net requesting to be added to the notification list for Fourth Axis Rotary, and then I'll know, and I'll send you the login information and the password, and then each time we have one of these, we will notify you. And if you've got a topic that you want us to talk about that you don't know anything about and you want to learn about it, feel free to post it up on the Facebook page, okay? And then Talley will see it, everybody will see it, and then maybe we'll do a little webinar on it, and we'll all try to learn together. So I'm going to close it out here. Thanks, Talley, very much. We appreciate everybody joining us. I'll try to have this posted up on the YouTube link here you can see on the screen within the next day or two. So I hope everybody has an enjoyable rest of their week, and thank you.